Hi friends, today I am giving a lecture on what is binary tree and what are the types of binary trees and what are the operations that can be performed on the binary trees that can be discussed in this video. First of all, what is binary tree? In binary tree, each and every node in the binary tree can have at most two children. That means a node may contain 0 child or a node may contain 1 child or a node may contain 2 children. So that means a node may contain 0 child, 1 child and 2 children. Okay, so now consider this one. Now this is a binary tree or not? How to check that this is a binary tree or not? So in that tree, now consider node A. Node A has how many number of children? 2 children. Okay, up to this point it satisfies the binary tree property. Now node B has how many number of children? 2 children, that are D and E. Node C has how many children? 2 children, F and G. Node D has how many number of children? 0 child. Node F has how many number of children? 0 child. Node E has how many number of childs? Only 1 child. Node G has how many number of children? Only 1 child. Okay. Now it satisfies the binary tree property because each and every node in that binary tree, it may contain at most 2 children. That means it may have 2 children or it may have 1 child or it may have 0 child. Okay, so this is the binary tree. Okay, now how we are performing the insert operation on a binary tree? Initially binary tree is empty. Okay, now I want to insert A into the empty binary tree. Now we have to create a node and insert the element A. So now it becomes the root node. It is a binary tree because it does not contain any childs. Okay, next element is B. Now B can be inserted as a left child of A. Okay, next element is C. So C can be inserted as right child of A. Okay, now this is a binary tree because this node A has 2 children B and C. Node B has 0 child. Node C has 0 child. This is also a binary tree. Now consider this one. So node A has only 1 child. Node B has 0 child. It satisfies the binary tree property. Next element is D. D can be inserted as left child of B. So A, B and C. Next we have to insert element D. D can be inserted as a left child of B. Next one is E. So E can be inserted as a right child of B. So this is the binary tree we are getting after inserting all the elements. So now we have to check it is a binary tree or not. Node A has 2 childs B and C. Node B has 2 childs D and E. Node D has 0 childs. Node E has 0 childs. Node C has 0 childs. Now it becomes a binary tree. Now consider this one. Node A has two childs, B and C. Node B has one child, that is D. Node D has zero child. Node C has zero childs. Okay, so all the trees satisfies the binary tree property. After inserting all the elements into the empty binary tree, this is the tree we are getting. Okay, so before inserting an element into the binary tree, first we have to check whether the binary tree is empty or not. If it is empty, whatever the element we have to insert, that element becomes the root node. Okay, next element can be inserted as a left child of the root node. After that, whatever the element we have to insert, that element can be inserted as right child of root node. Okay, so now the root node contains two childrens. Okay, next element we have to insert node B left child. After that, next element node B right child. Once B has two children, go for node C. Next element can be inserted as left child of C. Next element can be inserted as right child of C. After completing two children of C, next priority given to node D. In this way, we have to perform the insert operation on a binary tree. Okay, now consider second example. Consider the elements 10, 5, 14, 13, 11, 16 and 21 and construct a binary tree. Initially, binary tree is empty. Now, whatever the first element that is inserted, now we have to create a node and insert the value into that node. Now, this is the binary tree because it contains a single node. It does not have any children. Okay, next element we want to insert is 5. So 5 can be inserted as a left child of 10. So now 5 can be inserted as a left child of n. We have to create a new node and inserting the value into that node, and 5 becomes the left child of 10. Okay. Next element we want to insert is 14. 14 can be inserted as a right child of 10. So now we have to create a new node and inserting the value into that node. Now 14 becomes the right child of 10. Okay. So now node 10 has two childs. Okay. Next we have to given priority to node 5. Okay. Next element we want to insert is 13. So 13 becomes the left child of 5. So 10, 5, 14. So now we have for node 5 left subtree is empty. Now we want to create a node and inserting 13 into that node. Now 13 becomes the left child of 5. Next element we want to insert is 11. 11 becomes the right child of 5. So 10, here 5, here 14. So 5 left child is 13. 5 right child is empty. Now we have to create a node and inserting the value 11 into that node. Now 11 becomes the right child of 10. Right child of 5. Okay. Next element we want to insert 16. So 16 for node 5, left child and right child are completed. Next priority given to node 14. So now node 16. So 14 left child is left subtree is empty. So we have to create a node and inserting the value 16 into that node, and 16 becomes the left child of 14. Okay. Next we have to insert 21. So 14 right child is empty. Now 21 can be acts as the right child of 14. 13, 11, and here 16, and right child is empty. Now we have to create a node and inserting the value into that node, and 21 becomes the right child of 14. Okay. First priority given to left child. After left child is completed, next priority given to right child. Once for a node has two children, then given to the next node in the same level. Okay. So this procedure is repeated. So until all the elements are inserted into the tree. So finally, after inserting all the elements, so we are getting the binary tree. So this is a binary tree because node 10 has two children, node 5 has two children, node 14 has two children, and node 13 has no children, node 11 has no children, node 16 has no children, and node 21 has no children. Okay. Next, types of binary trees. So there are four types of binary trees. First one is full binary tree, and second one is complete binary tree. Third one is perfect binary tree, and fourth one is degenerated binary tree. So next we go for full binary tree.